remit of the catapult is obviously to help UK industry. We have a role to play to show how we can use the technologies that, in WMG's case, we've probably developed in the manufacturing sphere, and apply those to horticulture, perhaps to agriculture, to be able to benefit different industries. If we're able to automate some of the aspects of the process which are laborious and need heavy manual labour, these sorts of autonomous mobile platforms can really have a lot to offer.
Automation System Group, as part of WMG, we are trying to bring in new solutions, new innovative ideas to the UK. So we started working with AGV, which is the horticultural board in the UK. So after analyzing the companies, we arrived to the idea that there should be a common solution. And from that point, we start developing relationship with end user. So this is an autonomous guided vehicle. The platform itself is aimed to move a standard pallet. Our target is to carrying 120 kilos. This kind of solution could be affordable if we work properly to face the challenge. We are today in Valle Fresco, one of the main companies we've been working with, testing in this site to try to demonstrate how we could move pallets around, normal tasks they're doing every day. This AGV is the second part of the project. After 1 year, we arrived to a robot capable to navigate by itself, be in contact and have human interaction by introducing QR code, able to be read by a depth camera, and avoiding obstacles, which has been useful and has been tested in this site so far.
Having these machines moving around the system here would be saving possibly 2-3 people running around with trolleys, bringing pallets back, and it's just, the saving will be phenomenal for us.
The AGV is essentially working from a pre-scanned map. The sensors that we have active on the AGV are the IMU sensor, which is used to detect rotation of the AGV as well as the velocities. The AGV also has a LiDAR scanner, which is able to create a 3D scan of the local environment. It has a QR code scanner that can be used to scan QR codes offered to it by operators, and then this can correspond to a coordinate on the map. There are 2 additional laser scanners on the front and back, which are looking at objects in a close proximity. So the AGV is capable of operating both indoors and outdoors. It has a GPS functionality.
We should be looking at robots for planting, maybe even harvesting going forward.
After this project, we are planning to be working together with a technology developer to try to escalate this project to a commercial level and be able to provide a solution to horticultural area or agricultural area, which include outdoor and indoor logistic operation.
I think it's a very competitive market. If we're able to automate some of the aspects of the process which are laborious and need heavy manual labour, these sorts of autonomous mobile platforms can really have a lot to offer. We've shown with the team that have done an excellent job on this project, what we've been able to do to develop a pilot solution, which we're now refining to suit this particular use case. But if you've got similar thoughts around similar applications, we'd very much like to hear from you and collaborate with you to help develop viable solutions.